We're going to be discussing AI's role in the transformation of security. Please welcome our amazing panel, Helena Fu, Jeff Alstott, Jen Rochlis, and our moderator, Jake Seid.
Great, thanks everyone for joining us. We have a great panel today. A lot of amazing experience across the NASA, Department of Energy, RAND Group. So we're going to talk about cybersecurity and AI, but we're also going to touch on topics beyond that. I'm also going to play a dual role moderator, but I'll also jump in as the fourth panelist since we each bring a little bit different perspective. But let's start by each of the panelists just saying a quick bit about their background and how it connects into the world of AI and cybersecurity. Jeff, do you want to start?
Sure. Hello, everyone. I am the founding director of the Center for Technology and Security Policy, TASP, at RAND, where our mission is tech competition and tech risk. So beat China and don't die. That's what we spend a lot of time working on. And so we're deeply concerned about the effects of technology on national security and how it can be used for national security advantage, and that includes cybersecurity.
Hi, good morning, everyone. My name is Jen Rochlis. I started working in AI about 2000, late 90s. When I was at MIT, I was doing human-machine interfaces and human automation interfaces. And then I spent 20 years at NASA developing humanoid robots and rovers and fault detection, isolation, recovery systems for sending people out into space so that we could provide assistance for them along the way and offload dull, dirty, dangerous tasks that we didn't want the astronauts doing. So I'm very slanted towards humans in this space, which may not be the first top-of-mind idea when you think of security. But after I worked for the government, I went into private industry and I did unmanned systems for defense space. So high combat, high criticality locations where security is of the essence, and both for national and international governments. So I've been at this for a while, but you'll see today my scope is really about how we think of the humans as part of the system. So.
Great, and thanks. I'm Helena Fu. I'm the director of the Office of Critical and Emerging Technologies at the Department of Energy. This conference is about AI at the crossroads. I would say DOE is at the crossroads of AI for energy and energy for AI. It is also at the crossroads of science and national security through the work of our 17 national labs. So really happy to be here. Thank you.
And just a quick bit about me. Started working in cybersecurity back in '98 and currently run a cybersecurity-focused venture capital firm. And so we get quite a bit of perspective on what are the emerging threats that we have to deal with, how does that fit with emerging architectures like AI, and that's become a very important theme for us, that intersection of AI and cybersecurity. So with that, let's start jumping in for each panelist, starting with Helena. Let's talk about what do you see as the biggest risk that AI poses today, and what do you think the biggest risk in the future is going to be?
That's a really interesting question. So I talked a little bit about what the Department of Energy is, and I think for many people who have touched DOE, it's usually been the energy parts of DOE. So I think one of the things that we're really excited about, what the biggest opportunity, but also the biggest risk, is whether or not we can actually harness it to solve problems. And I think our firm belief is that DOE and the United States should be the place where we are able to get to first to truth, right? Solve those problems first for really this issue around strategic competition.
Jen?
We could point to a lot of the technical issues about like data poisoning and model hacking, but I would say for me, I focus really on the so what. So when we have a security breach for whatever industry it's in, what are we doing about it? How do we build resiliency after that? How do we triage it? If the AI is working at speeds greater than we humans can still, manage, how do we jump in and get off the bench and get really caught up to speed to know what to do about it? Historically at NASA, we shut down for multiple years when we have an issue. We can't do that in the future. And so I think figuring out how we deal with security issues, knowing up front we are going to fail and fail in spectacular ways. So how do we build the policies and guardrails to allow us to be resilient once that happens?
And Jeff, before you jump in, just for the audience, interesting background, not just at RAND, but also in the intelligence community, how the intelligence community has used AI. So I'm sure you've seen some interesting aspects of how people need to think about risk today and into the future.
Yes, so your question was about the biggest risk, I think. And this is often the subject of much sort of fights and holy wars, particularly within DC, because the simple fact is there are many risks, there are many problems, and people like to say, oh, the real risk is this, or the biggest risk is this. But in fact, there are multiple things, and we have to be able to walk and chew gum at the same time to address multiple different kinds of problems and opportunities. Within the cyber domain, I think that AI has been part of cyber defense forever. Right? So just automated monitoring and anomaly detection on your networks. We've been doing that for decades. What has the prospect of being possibly qualitatively new with frontier foundation models, which is the thing that is being discussed today and in vogue in general, is automated pen testing, where you really have a fully automatic cyber warrior, which can be used for both cyber offense and cyber defense. And I think there's a lot of interesting things there for those who are on the cyber offense side, but on the cyber defense side, you can be thinking about this fully automatic pen testing as sort of part of your stack for cyber defense. Maybe you're doing that in-house or you're outsourcing it. But this has the ability to be doing pen testing at machine scale and speed in a way that we couldn't really do before.
And is this something that you're saying is a risk today, or something that maybe sometime in the future it'll happen?
There are definitely startups now that are trying to use frontier foundation models to do fully automatic pen testing, which you can imagine having multiple uses. What they're finding using the models of at least a year ago was you couldn't really do it fully automatic. What you could do was greatly improve the human pen testers' capabilities and speed. Right? And so their business model was, I'm going to provide pen testing services to a bunch of different, Fortune whatever companies, but at a fraction of the cost or in a much more expansive way. So a question becomes, as the frontier of foundation models continues to expand, what will that business model look like? Will we get to the point of it's really fully automatic and it's not just the existing DEF CON attendee who's able to wield the things, but any 16-year-old script kiddie can wield the things?
Yeah, I think from our perspective, we have to assume that anything a good guy has, or somebody who is not in the kind of threat world has, the threat world will have that. And so if there are people here who are doing automated pen testing for good, that technology is going to exist, automated pen testing for bad. And something, a metaphor that we think about when you think about a cyber munition, sometimes people think about a cyber munition as the equivalent of a missile that gets fired, gets detonated. But that's actually the wrong metaphor, because when a missile gets fired and detonated, the person on the receiving end can't examine the missile, can't throw the missile back. And so really you have to think about cyber munitions as almost like biological warfare, where if somebody creates something that's very powerful, send it to the other side, well, it might cause damage on the other side, but now they have that same very powerful munition and can throw it back. And so that's one of the nuances of this world as good actors, bad actors go at it. From our perspective, one of the near-term risks that we see, we have a saying, misinformation is the new malware. And we tend to focus on folks who sell to the enterprise. We're less of a consumer-focused fund. But what's really been amazing in a very short period of time is the amount of and the power of synthetic media. And obviously, colloquially, deep fakes, whether it's voice, video, whether it's not real time, whether it's literally a Zoom of, it looks like the CEO is showing up, it sounds like the CEO, that CEO is asking for a wire transfer to be made urgently, that wire transfer gets made, and already different organizations have lost not millions, but tens of millions, not one organization, but many organizations. And so we're now entering a world where, amazingly, versus even just a few years ago, you almost can't trust what you see or what you hear unless you have some type of detection mechanisms to help you. I don't know, in each of your fields, have you thought about that? Have you seen evidence of that? Feel free, somebody jump in and talk about what they've seen.
So it was several years ago, maybe something like 7 years ago, when deepfakes were starting to hit the scene. And at that time, as you mentioned, I was in the intelligence community and getting asked to give briefings on this to the Hill or different parts of the executive branch. And everybody was asking about detecting the fakes. Indeed, that is still some of the conversation today. But what we were asserting at that time several years ago, and is sort of increasingly obvious now, is there is not a win condition that involves detecting the fakes by looking at fake content and distinguishing it from reality just by examining the pixels or whatnot. Because indeed, the tech will get better and better until there is literally no information gap between that audio file of my voice versus my actual voice. So what are the possible solutions? Amongst the possible solutions are technology that we've had for decades, which is cryptographic signatures of the media. We do this with our emails in some environments. We do this, on Signal and WhatsApp and whatnot.
That's that provenance.
Right. And so
it's created.
And so this is not telling you that the audio file or the image or whatever is a true image. What it's telling you is that this piece of media was signed, possibly at its creation, with a particular key, which you have reason to think that key belongs to a certain person. So in the case of email, is that I sign my emails with my cryptographic signature. You can tell that this email actually came from the sender who has my key. And so you can imagine a world in which that sort of capability is very standard, maybe even built into phone cameras and that kind of thing, so that you can be looking at an image like on here, and if it doesn't have the little like green check mark or QR code or whatever in the lower left-hand corner, then you're just going to sort of assume, oh, that could have been doctored. But if it has it, then you can scan it and say, yes, okay, that was signed by whatever original key, and that you may even have a provenance trail on that. And so there are different standards in development on this that NIST and others are involved with, things coming out of Adobe and other parts of industry. And this is what I imagine the long-term solution is going to look like.
I'll say in my industry, I worry about a few elements such as accountability and then trust deterioration. So especially when you start talking about putting these systems into forward-facing, human-facing, life-threatening situations like automated driving or other machinery operation, where is the accountability when somebody trusts a piece of data that turns out to be untrustworthy? And also I worry about it eroding human-human trust, because a lot of what we're doing is developing these human-machine, human team, human AI interfaces based on human-human teaming expertise that we've had for millennia, right? And when we all have talked about, right, the buildup of trust, the calibration of trust with these systems, and it's eroded like this, and then again, we're back to square one. So what is the recovery again of that? How do we share that accountability, and who do you point the finger at when that happens? And what is the backpedaling that we need to do to get back to the baseline? And what does it do to our human-human interactions when we feel like we can no longer trust one another? I think you're seeing right now the tipping point of what happens when we can't trust information. We put it back on us. Well, it's your job to do the homework. But if the homework is so darn good that I can't tell it from you, I think this is where I look at it in terms of the broader society impact too.
I mean, so I won't answer. I feel like Jeff and Jen really answered the question really well. One of the things that we're thinking about is about AI in the grid, right? So DOE is the sector risk management agency for the electricity sector. We're thinking a lot about what AI is going to do. These are massive, large loads that are coming onto the grid. They are straining in some regions what the grid is going to be able to do. And there is a potential for malicious use of that large load. So we're undertaking a number of studies there, but we're really looking at, again, back to this the risk of adoption, because I know, and we know, that there are other entities out there that are also looking to use this in an offensive way. So how do we make sure that as we harden our own grid and make sure that it is resilient, that we're enabling the entire sector to come alongside? And this is a sector that is the lifeline sector for all other critical infrastructure. So we need to make sure that the lights stay on.
Yeah, and it's almost a bit of a prisoner's dilemma where if you don't adopt it, then the competitors will, and so you have to kind of race to take some risk to get the benefit, and I think that's the challenge for everybody in this area of synthetic media. One of the interesting things a lot of people don't consider is we think generally, okay, how do I trust that image is real? But there's another element that relates to what Jen was talking about in terms of trust. Well, there's an image that might be real, and then somebody would say, that was not real. And this is called the liar's dividend in this synthetic media world, where now it's not just is an image fake and do we know it's fake, but this question of is it real and do we truly know it's real, or are we not able to tell that it's fake? And that's another huge important challenge in this space. Again, going back to this idea that we've now really entered a world where we can't necessarily trust what we see or what we hear unless we actually have something to help us with that. One of the other areas that we're marching forward towards is this notion of AGI, and it's going to happen in phases. There are going to be areas where AI is more capable than humans in certain areas, and so what are your views on how do we check something as humans that is actually more intelligent or more sophisticated than us? Maybe Jen, do you want to start with that?
Sure. It's a really interesting question because to me, it's a very philosophical one at the end of the day. When we did this in the industry for spaceflight, we talk about crew resource management. And when you do good requirements at the outset and you have a mission you're trying to perform, you determine what agent is best suited to perform that task that day, right? So it's a lot of real-time task management, task switching between different agents who are capable in different ways. And so we are going to be asked to get really uncomfortable with giving up some of the reins that we've been asked to take on for forever, as we realize that we are getting outpaced, right? And that's happening now already, so that's not news. But the challenge then is how do we lean into that dynamically and create more of a symbiotic AI? And I actually think that artificial as a word that we use to describe AI is a little bit fear-based in and of itself. I like to use the term intentional AI because we have to develop these systems intentionally to say we are intending to be partners in this and we are going to take the reins when it makes most sense for each of us. And that dynamic resource management of who's going to do what it allows us to do is then really think critically about what is our contribution as the human in that space. Where do we get to evolve differently? We talked about this a little this morning, right? Where do we get to push the boundaries of our consciousness and our exploration, our creativity, when we are moving away from the task, masters of all things, to the ones who have to admit that there are things that we need to relegate down to the AI or across to the AI if we're going to partner with them. And where does that symbiosis then happen? And when we design the systems at the outset with the human as part of the system, with the AI, that's, I think, where we can really make the strides. So I would love everyone in here to sort of redefine the word system in your mind, to believe it's hardware plus software plus human, and not the system is the thing that you hand to the human to use. And when you do that, you create different outcomes. And if you want to talk about ROI, like we did this morning, there's a whole conversation to be had on that's how you get the ROI.
Jeff, Helena, how do we check the superintelligence that will exist?
It is a very philosophical question, and I think it's not quite as binary as the sort of we all make it out to be. I think there are going to be many facets of intelligence. I think, and we're really, it's been remarkable the advances in AI, even from 2 years ago till now. Our labs have been playing around with a lot of these models and really evaluating them for scientific capability. And with a new technique and coming out from OpenAI, we're really seeing market improvement to sort of PhD level performance. But really, that only and no matter really, I think how good these models end up becoming, they really only bring you to the door of institutions like DOE and the national labs, because these models will be really good at developing amazing hypotheses that may prove out. But you need that connection to the physical world to actually solve a problem, right? You need to be able to fabricate a material. You need to be able to test it to see if it works in a safe way so that you can use it for the highest consequence missions. So that's the kind of intersection, the place that I think still needs to happen. There needs to be that kind of deep partnership to really move all of this to that next level.
Jeff, actually, let's jump to your experience understanding the Asian countries, their capabilities. Where is the U.S. relative to other countries in offense, defense? How should we think about that?
Offense and defense on
cybersecurity and how AI might be changing that.
I think I may have too much guilty knowledge on this one, so I may not be able to answer your question as asked. In broader sorts of forms of sort of trans-Pacific competition on AI writ large, sort of leaving aside cyber, there is a dynamic that has unfolded over the past 2 to 3 decades where the U.S. has been the research lab of the world and China has been the factory of the world. And that is obviously not true in absolutes. There is certainly manufacturing and implementation and commercialization that happens in the U.S., and there is research that happens in China. However, we've had this dynamic where we in the U.S. have been really at the forefront of developing tech, but China is increasingly good at the implementation and commercialization of it. And this is a dynamic that could be fine, and there could be gains from trade there and everything, as long as they're in fact mutually beneficial gains from trade. And what we have seen sort of across 2 administrations now is a recognition that the paradigm of the U.S. Goes and figures out new technology and then quickly loses any IP edge there to others like China, does not actually pay the bills for the U.S. And so figuring out how to still advance the frontier of technology as quickly as possible in the U.S. while controlling the effects of those technologies for the purposes of American prosperity, security, and values is really one of the sort of key questions of technology policy for the U.S. these days.
Yeah, and it's a very tricky subject. Obviously, there's been a lot in the news around who has malware where on people's infrastructure, and generally something that I'd add is look, the U.S. is very good at offense. There's a set of countries that are also good at offense. One of the challenges that the U.S. has to think about is defense. And the U.S. doesn't have a national digital border. Other countries can create a national digital border. Other countries can gather signal and intelligence and data from their largest companies and use that for a coordinated national defense. We can't. And so that's one of the asymmetries that we have to think about. We could push the frontier of offense, but again, this is not a munition that explodes. This is a munition that if we use it, it goes into the hands of others. And so defense becomes very important. And one of the key things that we have to think about is how do we continue to bolster our defense? Because that's probably where we're lagging the most.
And there are things that we can be doing that we're not presently doing today with frontier AI that I'm optimistic could get rolled out in the next few years. So for example, recall my previous sort of highlighting that frontier foundation models will help people do automated cyber warfare. And an example of a specific move in there is just finding new 0 days, just reading through code and finding vulnerabilities. And so you could imagine a regime where every time a new frontier foundation model comes out, say CISA, the Cybersecurity and Infrastructure Security Agency, takes that foundation model and runs it against a probably large stack of code used in critical infrastructure. So just sort of all the open source packages that people are using and some of the proprietary software, and just runs the model against all that, trying to find new 0 days. And the purpose of this is for the defender to know the 0 days before the offense does, right? And then you go through the responsible vulnerability disclosure process and get all those patched, and then you roll out the foundation model, right? And you can imagine doing that over the span of a week if you fully automate it. So these are the kind of moves that a defender could be thinking about doing.
There's a non-cyber related question that I think is important given Helena's role, which is a lot of people here are interested in, is this idea of how can AI be used to accelerate clean forms of energy? And how are you thinking about that? How hard is the DOE pushing the frontiers of AI specifically in that area because obviously if you can affect a change and create, some breakthrough clean energy, that actually solves conflict regions, that solves a lot. And so tell us what the DOE is doing on that front.
Yeah, I mean, we have a few Earth shots, which are really, really bold numeric targets that we're setting for things like long duration energy storage, which will have huge implications for energy scarcity and energy availability. A lot of these are going to be materials questions. How do we develop, identify, discover new materials that have not yet been invented yet? So we are really excited about the opportunity of AI in this space and its transformative nature. And I think the key here is the speed to discovery. The speed to discovery in discovery science. I mean, things that would have taken years, now taking weeks. That's tremendous and huge. We think that it's going to be transformative for the energy space, both in terms of how you manage large complex systems like the grid, or how you can think about, and we're already doing this really, in trying to make advances in fusion, as well as how we can harness AI for our national security missions. And so we recently launched a roadmap for an initiative called Frontiers in AI for Science, Security, and Technology, which is really about what a capability in AI should look like in the U.S. government. And DOE has had a very long-term role to play in the AI ecosystem in stewarding high-performance computing for the country. Yeah. So we're really excited about it. I think we're going to need to develop new ways of partnering, both with industry and with academia. So we have a request for information that's out there that asks a lot of questions about how we should be harnessing our data. So DOE collects and generates the most, or if not the most, then the top few of unclassified and classified scientific data in the world through all of our scientific infrastructure. These are X-rays, particle accelerators, light sources. How do we harness that? And a number of other questions besides.
And just continuing the role of the DOE, one of the other frontiers that will have a dramatic impact on AI, on cybersecurity is quantum. DOE plays an important role there. Give the audience a sense of where is quantum at, separating hype and reality today. When does it become real and usable? What's your view on that?
Well, there's sort of AI is here today, right? And we're all sort of here because we're trying to think about how we can harness it for our mission.
Or on the quantum side specifically.
On quantum, we have a number of centers that are based at the national labs, but bring in industry and academia to help look at advances in sensing, materials, processing. It's further out. But one of the exciting things in this space is that our Office of Science recently signed an MOU with DARPA to do benchmarking of quantum, because there's a lot of hype out there. There's a lot of, we should apply quantum to the grid. These are the kinds of things that we're trying to work through, and that benchmarking exercise will really look at what the performance is like from a scientific basis. So keep your eyes out.
Is there a DOE estimate? Is it, kind of order of magnitude? Is it 5 years out? Is it 20 years out?
Well, you know what they say about fusion, right? So it's very hard to put people in the position to make that. But I mean, we do see the promise, and we see some early indication of and sort of scientific advances. But there's so much more in the R&D space that still needs to be done.
Jen, one of the things that we're moving into is agentic AI, and given your work, human-centered systems, how do humans and AI, what's your view on the right modes of interaction? Is it kind of us and them, or are they an extension of us? What's your expectation of where agentic AI is going to place the role of humans in the future?
Oh, that's a big question.
That's my job. Ask the big questions.
Great question. I will say, I hate to say it depends, but it does. I think what I've seen so far, is the way that people approach interacting with AI systems depends on the nature of the interaction with regards to whether it's purely software-based, purely hardware-based, and what connectivity is required to harness the power of AI out of it. So for example, from a mechatronics perspective, when you put AI on a robotic system, whether it's going to do part of the tasks for you or be your robotic assistant or tool caddy or your rover that's going to plan tasks for you and navigate and such, you see them, it's very, very easy to anthropomorphize everything. And we have lots and lots of data, and you all are all very aware that we do this, right? Even with our phones and ChatGPT. So there's a real drive for humans, if you've noticed, to try to get a handle on how do I relate to this thing in a way and with a framework that I have already evolutionarily developed, right? I don't want to think of it as an it. Other people are very much like, it's an it, it's a tool, don't come near me. I don't want to get comfy with you because that's how I feel safe. I need that barrier between me and you. And so you have this group of folks who are really trying to blur that line between the human and the automation and the AI and create it as a partnership. And I do believe that, like I said, symbiotic is where we're going, and shared consciousness would be amazing. And if you think about it, what ChatGPT is doing is creating a unity consciousness with like all of us as the inputs, right? So it's getting closer and closer to understanding how we all want to interact with it by learning. And then you have another group, which if it's truly like a software piece, it's a little easier to keep it as more of a tool-based, right? So, for example, in my world, we'll use AI on the edge for, let's say it's in space flight, we'll use it for fault detection, isolation, and recovery, as we call it, FITR, meaning something goes wrong in a habitat or a spacecraft. I can't possibly know all of the inner workings of every system on that spacecraft or habitat. You've got to help me, right? So I rely on it as a tool. And in order to rely on it, I have to build that trust and all the calibration we've talked about earlier. When you talk about defense systems, so when we were flying unmanned systems in defense spaces, what's interesting there about where you want to interact with it is now all of a sudden the criticality of the decisions that you are making based on the suggestions is much, much higher. And so even though I want to trust it, there's a standoff again. And when you have the people who are developing the AI models are completely walled off from understanding the inputs in the training data, right, for security reasons. Like I can't know what I'm training the data on as the operator, and the person in the field who has far less training than the person who developed the algorithm has to make a real-time life-threatening decision with that information. How we choose to let our guard down, so to speak, and let that help us, it's a very iterative process. And I think one of the biggest disservices that we did was hold on to AI for as long as we did before we let it out in the wild. Because I'm very much a proponent of early and often integration and release, right? We talk about build and test. We've got to get it out there because, as we all know, humans will interact with it in a way that we don't expect. So many unknown unknowns. And we need to keep asking ourselves, what haven't we asked already? What are we forgetting to ask ourselves? If you would do it, the AI would do it. So it is not far off from us, but also, last thing, very philosophically, AI becomes a mirror and a reflection of how we see ourselves. And so things that we sometimes don't want to believe that it can do or will do, it makes that uncomfortableness even greater to the forefront. So we take a look at our risk posture and our risk tolerance, and depending on your industry, where are we comfortable inserting this, and how do we turn the dial, and how quickly do we accept this? And so, yeah, that was a big answer for it depends. Sorry.
And Jeff, again, this idea that ultimately we're using AI right now for information, summarization. It's quickly going to move into the world of taking actions, autonomously taking actions. You've studied some of this. What's the responsible way to roll out a new generation of AI that's autonomous and action-taking? What have you thought about? What have you researched on that topic?
I mean, I really just wanted to answer my emails for me. What did I think? I wanted to answer my emails for me, right? And we say that in a little bit of jest, but a lot of sincerity. And the issue is that we know we can't just hook it up to our email because it's going to do all sorts of stupid stuff or bad stuff and wreck our company or our operations or whatnot. And it's your level of trust in the system needs to go up a lot if you're talking about giving it really unbounded movement ability, right? And I mean that, yes, in terms of physical movement, but also in terms of movement in a cyber domain or sort of in terms of your organization's business logic, that kind of thing. And so the classic answer is to be doing sort of domain-specific testing or action-specific testing and build a sort of deep, or at least deep enough understanding of what validation verification is, that the tool can do the job. The difficulty with increasingly generalized intelligence is that we want to be throwing the kitchen sink at it, and we just do not have right now the ability to scale that validation and verification regime to arbitrary tasks, especially tasks that are in a changing environment or involve a multiplicity of different kind of factors that are in play in the task, which might be the case when you are handling a really thorny email, right? And so I'm actually like pessimistic about where we are right now, about our ability to do adequate V&V for that. And so it's an area that we need a lot more sort of R&D on, because I really wanted to answer my emails.
And then we're going to live in a world where my bot talks to your bot. We never talk to each other.
And then we can just go hang out.
We can just hang out. One of the ways I'd extend that as well is today we're in a world where we're talking about people build an agent that starts to take action on our behalf. How do we verify that those actions are appropriate? The next nonlinearity that happens is the tool builds itself to take actions, and those actions then allow the tool to build itself to take new and more capable actions. And this is one of the design criteria for some of the large foundation models out there, is ultimately not that humans write the next version of it, but it writes the next version of itself. And so this is something that we're going to wrestle with, I think, over the next couple of years, is not just autonomy, not just taking action, but the natural or the capability of the tools to decide what action they're going to take as they continuously rewrite and upgrade themselves. And so that's something else on the security front we'll have to watch out for. Helena, one of the things that we have to talk about, given your role, is in the recent news, Google and others buying nuclear reactors, right? AI is impacting the grid. AI is impacting the global demands for energy. What's your view on how that plays out, for positive, for negative? How is AI's energy demand shaping how the DOE thinks about our energy infrastructure?
I think this is a great question. And frankly, a lot of the way in which this has been reported is not entirely accurate. I think a lot of it is a realization that energy demand is rising again after a decade of no growth, right? But we've been here before. We've been here in periods where energy demand has grown 30% or more. And I think the difference now, as compared to previous periods of load growth, is that we have new tools through the Bipartisan Infrastructure Law and the Inflation Reduction Act, tax credits, grants, loans, and new technologies that were not available 20 or 30 years ago. So we think this is actually a moment where very well-resourced companies that are focused on building huge data centers for training AI. By the way, it's not just AI that's driving this demand. It's also manufacturing coming back to the United States and broader electrification of the grid, which is a good demand signal, let's not forget. But we recognize that there's a regional nature to this issue, right? Like the energy demands are not happening all over. It's specifically in certain areas. And so DOE has been very, very focused on this, working very closely with the White House, working very closely with other federal agencies. And in the National Security Memorandum that was just released, we're going to be taking a leading role in making sure that we're able to really speed forward, both find efficiencies in the permitting process, but also really think about what can be done in the near term through grid reconductoring, grid enhancing technologies to allow for more power now and in the near future, but also what are the things we can do in that sort of 3-year time horizon to really accelerate energy availability.
Great. I think we're coming up on time, so maybe each panelist provide a closing thought, and then we'll wrap. Jeff, do you want to kick it off?
AI is awesome. We should be doing more of it, and we just need to do it in a slightly mindful way.
Best ROI we can get with our AI is to design it with human partnership from the outset.
I think a lot of our focus has been on text-based large language models. The thing that is most exciting to agencies like DOE is the opportunity space to really develop models with industry and with academia that will understand science to solve our problems. And that is what we are excited about deploying AI for.
And I'd leave it with, oftentimes when you talk about cybersecurity and AI, it can sound very pessimistic. It could sound like, almost fear-mongering. I think the important thing, though, to realize is that, while there are risks, there's a lot of very capable and smart people working on how to manage those risks. And ultimately, over the course of many, many generations of different technology architectures, we've had new risks that have come up. We've found ways to manage those risks. So despite sometimes the pessimistic and fearful tone, as a practitioner, or someone who lives in this space, I'm very optimistic that we'll find the right solutions as well. So thank you to our panelists, and thank you for joining us.